Hello, welcome to another video for biology. This biology is a more advanced, in-depth look at the Krebs cycle. So we're going to take a closer look at each step-by-step process of how we end up. We started off with pyruvate and basically end up in the electron transport chain. Okay, so the previous video we highlighted this section. Okay, how pyruvate turned into acetyl coenzyme A. So let me go ahead and just review this particular part real quick. Remember, we're not in the Krebs cycle yet. Right now we're prepping the molecule to go into the Krebs cycle. So with pyruvate, we have pyruvate dehydrogenase, okay? In conjunction with NAD, we have a high energy electron that's stripped away from pyruvate, and pyruvate dehydrogenase aids in extracting a carbon from the 3-carbon molecule, turning it into a 2-carbon molecule. And then you have a coenzyme, okay, that attaches itself to this acetyl group, which is the 2-carbon group right here. So we end up with acetyl coenzyme A, which is now ready to enter the Krebs cycle with carbon dioxide as a waste product and NADH ready to go into the electron transport chain. So the process repeats itself with the next pyruvate with extraction of high energy electron and then getting rid of a carbon dioxide, and now we have another acetyl coenzyme A that is ready for the Krebs cycle. Okay, so again we start off with pyruvate, which is a 3-carbon molecule. We have a reaction that occurs where energy is extracted, and we end up with a 2-carbon molecule, acetyl coenzyme A, which is now ready for the Krebs cycle. So I'm going to go through a step-by-step process. This by no means is an exhaustive video of this process, but it's definitely a more detailed view of the previous video that I posted. So acetyl coenzyme A is right now ready to enter the Krebs cycle, and it combines with this molecule called oxaloacetate, okay, and it turns into citrate, okay, which is where citric acid cycle gets its name, and also the Krebs cycle. So that's the process that I'm going to detail next, okay, is how acetyl coenzyme A combines with acetyl oxaloacetate to make citrate. All right, so here goes. So again, my 2-carbon molecule acetyl coenzyme A will combine with the 4-carbon molecule oxaloacetate, okay. I have a reaction where my coenzyme ushers in my 2-carbon molecule, and I combine to make now a 6-carbon molecule called citrate, okay, citric acid. Okay, so citric acid now will continue on the Krebs cycle, and the next steps that I'm going to describe is how citrate will rearrange its atoms to become another molecule called cisinate. One of the things that I want you to keep in mind as citrate becomes cisinate, you got to remember the end goal of this entire process is to produce more ATP, or at least extract energy from the pyruvate or acetyl coenzyme A molecule so that we can then make more ATP. Okay? So in this process, you're going to notice that citrate, as it turns into cisinate, you will have energy extracted in the form of 2 NADHs. And anytime there's an NADH, okay, you're going to have, well, not anytime, but for the most part, most of the time you will have a carbon that, a bond that's broken where a carbon will break off in the form of a carbon dioxide. So 2 NADHs will coincide with the 2 carbons that will break off, and then you also have an ATP molecule ready to go do work in the human body. Okay? So again, 2 NADHs and ATP, those 2 NADHs coincide with the 2 carbon dioxide molecules that leave. Okay, so here we go. So here's the next step. Citrate, citric acid. Okay, my 6-carbon molecule, okay, I'll have water that leaves this molecule, and in that process, that's going to cause this 6-carbon molecule to rearrange itself into what's called an isocitrate. Okay, iso referring to the fact that it's isometric. Okay, you have 2 carbons on each side of the middle carbon, carbon 3 here. Okay, all right. So you have 2 carbons. I'm sorry, you have a isocitrate. Okay, and then you're going to have an NAD. Remember, anytime you see NAD, you're going to have a bond that breaks, which means you're also going to have a carbon dioxide that comes off. So that carbon 6 molecule turns into a carbon 5. Okay? Keep in mind, that was my first NAD. So now I have my second NAD and ATP that's going to come off, right? Alright, so here's my second NAD coming to make more NADH. So I'm extracting energy. I'm extracting a high energy electron from my 5 carbon molecule, turning it into a 4 carbon molecule. And now my ADP is coming to extract even more energy from that 4 carbon molecule. Okay, and now I have my cisinate. Okay, so this is my cisinate molecule, right? So I went from citrate to cisinate, and now the next, and again I extracted 2 NADs, ATP, and 2 carbon dioxides. Okay, ending up with cisinate. And now the next step, or the next process I'm going to describe is how cisinate turns into malate. Okay, so cisinate is still an unstable molecule. It still contains a lot of energy, and then I have another energy electron carrier in the form of FAD. It's going to come along and it's going to strip 2 hydrogens away from this molecule, right? Becoming FADH. And now I'm going to add a water molecule. Okay, so I'm going to hydrate this molecule. And that process gives me my next molecule, malate, right? So from cisinate to malate, I produced one FAD electron carrying molecule, which will make its way into the electron transport chain, right? So now my last step, which is going to be describing how malate turns into oxaloacetate. Okay, so malate now still has energy to give. Okay, there's not a lot of energy left, but there's still some. So NAD will come in and form NADH. Now you'll notice in this case I don't lose a carbon, right? So the energy state of malate, when it turns into a more stable oxaloacetate, it's not necessary for it to lose or cleave off a carbon dioxide. So now I have oxaloacetate, which is my starting 4 carbon molecule that I needed to get my Krebs cycle started with acetyl coenzyme A, right? And that's my entire Krebs cycle, and this process just continues to go on. Okay, so here's again showing what energy carrying molecules I produce, and these molecules will then continue on into the electron transport chain, and then that's where we will pick up on our next video. Okay, so that ends Krebs cycle advanced, and good luck in your studying.